So I wanted to see if I could design a stiffer and better prod-off tool for 2-axis conventional lathes to be able to push them harder and reduce that cycle time. So I went ahead and mocked something up, made it, and tested it out. So let's take a look. Alright, so I'm running it at 250 surface footage. I start the cut at 5 thou per rev to get a start, to make sure it doesn't move around on me. And then I ramp it up to 12 thou per rev and push that through the material, finishing at 4 thou per rev just to make sure I don't mess up the insert at the end of the cut. So let's take a look at the design of the tool and what my considerations were when I was doing it. I wanted to make this tool as strong as possible, and so to do that I wanted to have the blade be as big as possible and then supported by a ring of material, kind of like a half I-beam type situation. So this is what I came up with. This can do 3 1/4 inch material and under. So if you wanted to do larger material, you would need a larger style. You couldn't just slide the tool in and out like you can on a regular prod-off tool. So it's got the blade thinness here that can go into the material. That's supported by this thicker piece of material, which is then bolted to the shank that goes into the tool holder. So let's take a look at this. I cut this channel in there, okay, and then put that right there like that. So now this, it hooks, this tool hooks in, and that keeps it so that it doesn't pull it down, and then the screws just hold it on there, okay. Now what I like about this is this goes straight down and then to this material here, so all of this is being supported, okay. And then this angle up here actually works pretty good at clearing the chips. It makes a nice ramp to ramp those chips out of there. And if I had some coolant going through this tool versus that flood coolant that I was using, I think it would do an even better job. Now this tool I made out of I just used inserts that I had sitting around and made out of material that I had laying around. And I think if I got a different insert and tweaked this a little bit, I might be able to do better than that 250 surface footage at 12 thou per rev. And here's the other thing, is I'd have to use a different machine too, because one of the limiting factors preventing me from feeding as fast as I wanted to was the rigidity of my spindle, okay. And that's actually why you see I was using a steady rest there, is because my spindle, after a certain feed rate and RPM, started to vibrate a lot. I was getting a lot of chatter and it just wouldn't let me feed it right. So I had to reduce the load on the spindle. So what I did was I put my steady rest right in front of the chuck, so that when I'm pushing down, parting off, a good amount of that load is going into the steady rest and then into the casting of my lathe, rather than into that spindle and then causing a bunch of harmonics. So all in all, I think it was a pretty cool tool and a nice experiment.